Okay, now it's being recorded. So the learning objective of this chapter is basically capital budgeting and the difference between the short term and the long term. We'll explain the payback model and its two significant weakness and how discounted payback model is being addressed one of these problems. And another issue about the NPV decision, where the modern and appropriate discount rate will be used, where we'll appreciate why it's being preferred above the other criterion. We'll calculate the most popular capital budgeting alternative like IRR, MIRR, and we'll try to understand the profitability index as modification. And we'll compare and contrast the strength and the weakness of each decision model in holistic way. First of all, long-term decision versus short-term decisions are differentiating from each other in terms of the long-term horizons and with the cost too. The long-term projects, long-term decision, capital budgeting has got the costs which are higher as a sum of the money and require a lot of more information to be collected as a part of the analysis. So capital budgeting meets all the criteria. Basically, capital budgeting is all about making and identifying the long-term investments. Like if you have any long-term investment, then you're trying to come up with this project. So, and in order to come up with this project, you have to decide whether the certain project is profitable or not. And this investment criteria we will be using that will help us to understand whether certain projects will be accepted or not. So we'll start with the payback period. Payback period, as the name suggests, that how long it will take to pay back the investment that you made it when you started a certain project. And basically the payback period has got a cutoff period, which is the goal that you set before running the project. You say like, I want to get my money back in 10 years or in 5 years. If the investment project takes more than that, what you have just said, then that project cannot be accepted. So the method, you assume that all cash outflows occur right at the beginning of the project's life as a stream of the inflows. And also you assume that the cash inflows will occur uniformly over the year. So imagine you're given the cost of 40,000, cash flow of 15,000 per year for 3 years, and you've got payback period 2.67 years. How it's been calculated, I'll just show and illustrate in Excel. It's basically here. So we have cost, which is 40,000, but the cost is always negative, as we know. And we have 15,000 each year generated as profit. So how long should it take to cover the investment cost? This is all about the payback period. So basically what you're going to be doing is subtracting from the investment costs the money that you earn in the first year. And that shows that 25,000 will be remaining. Then in the second year, you earn another 15,000. Then you will subtract this 25,000 again, and you have remaining like 10,000. But in the third year, you generate more than you needed to cover it. So it means that you just fully used 2 years, and the third year will be used some part of the money, like to cover the whole investment cost. So to calculate the exact payback period is basically 2, because 2 full years are used here, 15, 15, and only the third year cash flow will be used partly. So plus, why plus? I'm going to add 10,000 divided by 15,000. So it means that 10,000 that I need to cover, I will get it from 15,000 of the next generated cash flow. That will help me to understand in ratio how much it will save in terms of the number of the year. But to remove this negative sign, you have to put some negative sign here too. The impact of this negative sign, we need to remove it. We just put the negative sign here too. And 2.66 years, you will need it to cover it. Like if you like 2 years and 66% of 1 year means like more than 2.5 years, you will need it to cover that investment. That's all about the payback. So let's say the owner of the Perfect Images Salon considering the purchase of the new tanning bed. The cost is 10,000 and it's likely to bring after the cash inflows of 4,000 the first year, 4.5 in the second year, and 10,000 in the third year, and 8,000 in the fourth year. And the firm has the policy of buying equipment only if the payback period is 2 years or less. So you put the cutoff period, you say that I'm not going to accept this project if it's not going to bring me my money that I invested like more than 2 years. I need it like this project if it's less than 2 years. So again, 4,000, 4.5, 8, and 10 and 8. Now, for this, you need to, again, subtract this investment, this cash inflows. As you can see from here, actually, in the third year, you will generate the 10,000, but you need only 1,500, which is like much, much, much less than what you needed here, actually. So basically, you have used fully 2 years, and from the third year, you're going to get just part of it. Again, my payback period will be 2 plus, again, I'm putting the negative sign to remove this negativeness, 1,500 over 10,000. Again, why over 10,000? Because we're going to get this money from the 10,000 itself. So my payback period is 2.15, which is more than we just set as a goal. Our goal was 2 years or less. Or we put the cutoff period like less than 2 years. That means that we cannot go with this project. So we better stop. So we will reject the project. So you put the goal. If it doesn't meet that goal, then you need to just either reject or go with it. So the payback period method has the three major drawbacks. First, it ignores all cash flow after initial cash flow has been recovered. Like we actually don't care what's going to happen right after. As you can see, the first cash flows is double less what you will have it next right after the second cash flows. Like it's just less, but it is the most like significant. But for the payback, it doesn't matter. Like the payback, you need just to cover like the cost. That's the main disadvantage. The second one, it ignores the time value of the money. Like as you can see that we did not consider any time value of the money here. And the third, it ignores the riskiness of the cash flow. So we calculated time to take to cover the initial investment and discount the dollars and incorporate the time value of the money. Then you just calculate how much time it will take to cover the cost. Basically, you will need to just discount this value, let's say with a 10%. I will have to discount each values with a 10% discount rate, like 4,000 divided by 1, 10 to the power of 1. So I will bring to the year 0. So 4,000 in year 1 is equal to 3,600 in year 0. And similarly for this, 10,000 in year 3 is equal to 7.5 today. 8,000 in year 4 is equal to 5,400 in today. So this is discounted cash flows. What you will need to do here, basically, again, you will need to just subtract from the investment cost until you get the positive sign here. Oops, my bad. As you can see, it becomes positive in the third year, so we'll stop here. So basically, we will need it to cover 2,644. But in the third year, discounted value that will be generated will be 7.5, which is like double what we needed. So again, the payback period will be purely we have used 2 years plus, again, I'm putting the negative sign, minus 2 divided by the amount that we will be using it to cover that cost. So 2.35 years will be required to cover the investment cost. If you compare to the previous scenario to this, like it was like 2 point, not this one. In here, it was like 2.15 without discount. Like with discount, it will take even more. Okay, you discount the values, as we said, then you take the investment cost, and then you just make your payback estimation. Any questions? Okay. NPV, it's another investment criterion. As it has been mentioned from the beginning, it's just kind of prior investment criterion that we'll be using it, and your decision purely should be based on the NPV. Even though the others investment criteria will be given to you, but the last resort, the last decision-making process should be based on the NPV. NPV is basically present value of all future cash flows. You add them up and subtract the investment cost. And after that, if your NPV is more than 0, you accept the project. If it's less than 0, you reject the project. And this is like, again, you discount each cash flow using the value, using the, I'm going to call it payback here. And NPV, it's basically you discount each future cash inflow, you add them up, and then subtract the investment costs. Will give you the or net present. So I'm going to add all discounted values that I have it here. Plus, why plus? I need to subtract the investment cost. So as you can see here, I have a positive number here, which is good. So I have a positive NPV. So I can say that my project is profitable. I can accept, though it did not meet my payback period goal, which I set as like in 2 years or less, it should be recovered. But there's a function we can use it, NPV function. Last time I showed you too. It's 10%. We select the values, but you select not discounted values. You select the raw values before the discounting. Close it and again subtracting the investment. Okay. That's the way we get it, either through the function or manually, then add them up and subtract the investment cost. Any questions? Okay. Again, it's just straightforward calculation, and you need to just know. Again, we have payback, we have discounted payback, you have NPV. Your last decision should be based on the NPV. So NPV approach useful for independent as well as mutually exclusive. The difference between independent project and the mutually exclusive project is that when it's independent means that you can select both projects if they're positive. In mutual exclusiveness, cannot give you the chances to select both. You can select only one project. Even though they are both positive, still you can select only one due to some constraints. So there is a scarce resources that both projects need to buy, using it not available for the second, and there is need to for only one project. Both projects can fulfill the need. So NPV rule consider whether or not discounted cash inflows outweigh the cash outflow emanating from a project, like the cost that we have it. So again, this example is given. I'm gonna get it and put it in Excel. Okay, here we go. And 10% discount rate, okay. So I'll have to remove this signs. Okay, now I can calculate NPV for both projects. Again, I'm gonna use the function. So 10% discount rate, select the values. I'm not selecting year zero value. And pull into the right. That's what we have it. So two NPVs, both are positive. Again, if it's mutually exclusive, then you have to select one. And the one which is with the higher NPV, with obtaining bet. Okay. Sometimes projects may have unequal lives. So that unequal lives where you'll have to make them standardized and make them to more common way of estimation, then you can make a decision. So if it's unequal life, there are two approaches are used to solve that unequal life issues of the project. The first one is the replacement chain method, and the other one is like equivalent annual annuity approach. When it comes to the replacement chain methods, with the same project, okay, let's say we're given the same projects, but the project B doesn't have any. Let me get it to. Okay. So this is. I'll look in this way. Okay, everything is good. Now, one project is 4 years, the other one is 3 years. So in here, basically, is what you're gonna do is just make the number of the years of the project common number that could be divided by both number of years project. Like in one is 4, the other one is 3. So the common number that could be divided by both is 12. Like 12 divided by 4, 12 divided by 3. So in other words, if you want to put it, is simply to say that this project will be repeated 3 times. So both projects will be increased to 12 years. But before doing that, guys, before doing that, just want you to see the NPV of it. The NPVs are calculated, and you can see that. Project A tells you to select 10,000, the project B gives you the NPV 8,000. So if you calculate the NPV of this, again, 10%, selecting the values and investment cost, rate 10%, selecting the values, and investment cost. So based on this approach, we can see that project A is more preferable because it has got higher NPV. However, we cannot make any decision like this because the number of the years of the project they have both are different. We need to more like make it more common wise. So we need to increase it. So basically what I will do, just copy it again down and put it here and increase this one to 12 years. So 12 years. So my project A will be repeated 3 times. My project B will be repeated 4 times. And when my project A ends in year 4, when it comes to an end in year 4, it will start again. So at the end of the 4th year, this project will generate 8,000. At the same time, we will spend again 10,000 more. So the net amount will be here minus 2. So 8,000 minus 10,000 minus 2. Then the cash flows will be repeated. Again, here you're going to generate 8,000 and 10,000 should be invested. And the cash flows are repeated. But the last year, 12th year, you generate 8,000, but you don't make any investment because here where you will end your project. That's it. Your project will come to an end. Okay. And when it comes to B, it's the same story. The B will end in year 3, and we'll subtract investment costs of 5,750. So the remaining amount is this. So again, this will be repeated. In the 3rd year, 9,000. This cost, again, cash flows are repeated. 9,000 generated in the last year, and again, the investment costs will be down. And the last one here and 9,000 here, and you don't do any investment. Okay. Now, all cash flow are standardized in terms of the number of years. Now we can calculate the NPV for these 2 projects. So open NPV 10%, selecting the values. All the values should be selected except the investment cost, except the initial disinvestment cost. And we subtract this investment cost like this. All initial cash inflows, outflows should be selected. So again, NPV function, what it does take the present value of all future cash flows, add them up, and then you subtract the investment costs separately. And your NPV from this project is 22,210. And you just pull it to the right, 22,925. Now from here, you can see that the project B is more preferable, but in the previous case, the project A was preferable. So as you can see, some misconception, some misinformation, or it can be misunderstood when you just compare 2 projects with a different useful life. So you need to make them more standardized. Okay, is that clear?
So if we are given in the problem the different number of years, like in this example, we have to extend it to
a common number that could both be divided. Like 4, 5, common number, 20. 2, 3, the common number, 2, 3, 6. Okay? So basically, how can you calculate the common number? Just multiply these 2 numbers together. Okay? That's the way you can get it. And another approach, equal annual annuity approach. I'll just copy again these values. Yeah, the second way of doing that is basically it's equivalent annual annuity approach. It's basically we calculate the PMT. So rate is 10%. Number of period is in the first project is 4. And present value, it's an NPV that you estimated. You just select, but with a negative number. And the same thing you do for this. PMT rate is 10%. Number of period for the second project is 3 years. And the present value is this. So again, as you can see, the second project is preferred. So these two approaches, they give the same results, the same decisions. Okay? They never vary from each other. But both should be known by you. So you should know both of the approaches, how to use them. Any questions? Okay. Then we move on. Okay. So example is given again with NPV, guys, here. Year 1, year 2, year 3, year 4, year 5, with the cost of capital 12%. Calculate NPV, and the cost you have like 750,000. Basically, what you're going to do again, you're going to just take the present value of each cash flow, add them up, and you just subtract the investment cost. If it's more than 0, then you go with it. If it's less, you don't go with it. So again, as you can see, it's a negative number, so we can just repeat it. Okay, just let me delete this. Just, oops. Now, and minus 750, we said, yeah? 0, 1, 2, 3, 4, 5. So NPV, it's basically 10%. The values are here, plus investment cost. Did I do something wrong? What was the cost of capital? 12%. That's why I don't get that number. So 75, minus $71,000 means that this project should not be accepted. You directly reject because it's less than 0. Is that clear? Guys, am I fast? Okay. I will share this file with you, okay? So I'll just let me. I know we did this NPV stuff with you, but still I'm just very quickly to review it, okay? Just to make the things to set down in your mind so you don't have any other questions that may arise, okay? NPV 1, NPV 2 example. Okay. And what else? This is we've done it. Okay, IRR. Again, IRR is the rate. Second, let me just save it here so that it doesn't get lost. Okay. What's going on there outside? Even it took my attention too. So IRR, it's the internal rate of return that makes your NPV equal to 0. So this is the rate at which NPV will be equal to 0. Means that there is actually inverse relationship between discount rate and NPV. For example, I'm just going to put 12% here. And if I don't use the value here and put this one here, if I change this one to 2%, see what happens to NPV. My NPV becomes positive. If I increase it to 5, or if I make it, let's say 10, so my NPV reduces. So there is an inverse relationship between discount rate and NPV. As discount rate goes up, NPV goes down. So IRR rate is the rate at which NPV will be equal to 0. For example, let me calculate IRR. IRR is, you select the values, so 8%. So it means that at this rate, your NPV will be equal to 0. Let's taste it. Let's test it. Now, I put 8.46, as you can see it. I use the IRR rate. This is discount rate. My NPV becomes 0. But look at here. If I use this rate, my NPV, oops, sorry. If I use, instead of IRR, I use the discount rate, my NPV becomes negative. But make it, this one, 8%. My NPV becomes positive immediately. Compare the IRR and discount rate. IRR is higher than the discount rate. If IRR is more than the discount rate, then your project will be acceptable. If IRR is less than your discount rate, your project will be negative. It's not accepted, it's rejected. So IRR is rate, it's a kind of boundary after what your NPV becomes 0, up negative. Look here, make it more clear. Make your NPV, to use this rate, 146, and your NPV will be negative because it's just more than 0.001, and it will make your NPV equal to less than 0. Make it even 145 and 7, 45, 7. More or less they're the same, but you can see that it's still going to be negative because it is more than IRR. So IRR is the benchmark for you to understand at which level the NPV will start becoming negative. So you see the IRR, okay, at this level, if my discount rate goes a bit above the IRR, then the NPV will be negative. Then my project will not be feasible. Am I clear? Okay. So that's all about the IRR. Basically, IRR is the hurdle rate or discount rate or hurdle rate. It's a minimum acceptable rate of return that should be earned on a project given its risk. And so for a firm, that it would typically be weighted average cost of capital that will be covered in corporate finance course for you. So this is another example, like I'm just gonna go skip it. As you can see here, this is NPV value, and this is discount rate. As discount rate increases, your NPV reduces. and it goes closer to zero, and if it continues to increase again, the discount rate, your NPV will become. So can you tell me from here, the IRR is equal to, as you can see, 41, somewhere here, you see? So after 41%, your NPV will start becoming negative. Okay, and of course, IRR has got some pitfalls. You should remember that all investment criterion that we will be using, they have some disadvantages, they have some drawbacks that cannot be relied on, okay? And only the NPV with the best alternative, with the best future of priority that should be used as last resort, we can say. So IRR has got the multiple IRR issue, and sometimes it becomes unrealistic investment rate assumption. Sometimes you can see that IRR return is like 75 or 200%, something very unrealistic and cannot be accepted. And so due to this reason, you cannot rely on that. For example, in Kazakhstan, many banking systems, they use the IRR, many. And why, like multiple IRRs means like in one project, you may have two IRRs. How can it happen? When there are more than one cash flow that happens with the negative signs. So this is the example where the IRR kind of intersect twice, like 5.62% and 27.78%. We can illustrate this example again. Let me just go very quickly. This is very important. Minus 11,000, 7.5, 7.5, 7.5. 4 times 7.5 and minus 20,000. So we can see that we have twice in this project when there's a two negative cash flow. 5 years, okay, if I'm not mistaken, yeah. I'll try to calculate two IRRs to show it to you. So my IRR of this project, if the first IRR is this, does it have 15%? No. How does it happen? It has. Sure. Yeah. Yeah, 6%, which is 5.75. Did I get the same? Yeah, 5.62. Now, this is my first rate, first IRR, and my discount rate is, which discount rate they use here? I don't know, but any, which, like some discount rate they use, maybe it's like 10%. If it's 10%, based on this, as I said, if the IRR is higher than your discount rate, then you accept the project. But in this case, you will not accept the project because IRR is less. However, we can see there's like two negative cash flow in the same project that increases probability or chances that in that project we'll have more than two IRRs. At least there will be two IRRs. So, but which IRR we should use, we never know. And that complicates the things. And the second IRR, it's basically we select again the values. And the guessing value, we put like 0.20. I'm just going to put it. Yeah. So as you can see, we have two IRRs now. But which one to use? It's the same project. The first one tells you don't accept the project, but the second one tells you accept. So you kind of misguided. So all the financial institutions in developing countries, they use IRR so heavily. Like they rely on that IRR so much. To solve this problem, modified IRR was introduced. They said, let's thus introduce the modified IRR that will solve the problem of this negative sign. So this is IRR 1, this is IRR 2. And MIRR, modified IRR, is basically, again, IRR is the rate that NPV equal to 0. It is the benchmark for you to understand at what level the NPV start becoming negative. Right after that level. So MIRR, it's basically, again, I'm selecting these values. I don't have any financing rate. I have reinvestment rate, which is my discount rate. So my IRR, MIRR is this. So my true value is this one. I will not accept the project. If you calculate the NPV, your NPV will be negative with this values, like as the MIRR suggests, like NPV selecting the values, but in NPV I should have put the rate 10%. Did I include everything correctly? Yeah. So look, first IRR tells you reject, yeah? Reject the project. Second IRR tells you accept. MIRR tells you reject. But NPV, accept. So your decision should be based on NPV, because the NPV only the investment criterion that uses to calculate a pure money that you will be generating from that project, because you are interested in money itself. So you can see that these investment criterions, they are kind of sometimes misleading. So you might ask question, then why we need to use them if they are misleading? Like why we are kind of learning them? So the idea is that to understand what is the black, you need to know what is white. Like they are just supportive. They are used as a support. They are not used as, what do you call it, the main decision-making criterion. No, they are just supporting your decision. The main decision should be based on the NPV only. Is that clear? Okay. Sorry? In English, please. No, why we should put the NPV, MIRR into NPV? No, we don't put it. Like MIRR is the rate at which your NPV will be equal to 0. This is the rate that makes your NPV equal to 0. And this is the rate to compare with your discount rate. If it is more than your discount rate, then you accept the project. If it is less than your discount rate, you don't accept the project. Okay, crossover rate. Crossover rate, it's another rate that makes the NPV of two different projects equal to each other. We have two different projects, but at specific rate, their NPVs will be equal. That is called a crossover rate. And the example, we have it here. Again, obtaining bets. First of all, we take the differences, like this A project and B project. We take the differences of these two projects, and we calculate the IRR for this project, And that calculated IRR will be the crossover rate, means at which both NPVs will be equal, is at which they both NPVs will cross the crossing point. Example, let's say I have another project minus 15,000, 7,600, 8,000, 8.5, and 500. And let's calculate the NPV for it. NPV rate is 10%. Values are this. And investment cost subtraction. As you can see, they're far away from each other, yeah? Very far. So what I will do here, I'll just take the differences as here, like this minus this, this minus this, this minus this. A minus B. And calculate the IRR. So this is the crossover rate. At this rate, the NPV of these two projects should be same. So I'll take the rate here. I hope it will work. Okay. So both are negative, but they're same. This is the point, and this is the rate at which they cross over. Is that clear? So I took the differences from A minus B. A minus B. From values that I got here, I calculated IRR. And this is the discount rate. I'll put it here somewhere. And I use this rate to calculate the NPV for these two projects. This rate is used to to see that the NPVs, at what rate the NPVs will be equal. At what rate the NPVs will be in the same level. I mean, this intersection point. This is where they intersect. Okay? Are we all on the same page? Guys, online guys?
Yes.
Yes.
Okay. Okay, modified IRR. This is the formula. If you are kind of to calculate manually, you're more than welcome. Like the formula is there. What you're going to be doing, it's like taking the future value of all positive cash flow and taking the present value of all negative cash flows, like from the future till to today, and raising to the power 1 over n. N is the number of the periods of the project itself, and minus 1. That will give you the MIRR. Or, as I showed you in Excel, how MIRR is calculated. In MIRR estimation, we don't put here refinancing rate, okay? We put the reinvestment rate. We ignore the financing rate, we just put reinvestment rate as discount rate, okay? We select all values, including the cost, but in NPV, when we select the values, we don't include the cost. We set up to the cost, and then the cost is subtracted. Is that clear? Okay.
Yep.
Calculating MIRR. Profitability index. Okay. PI, it's index like if you want to kind of elaborate more about the PI, it's like $1 spend, how much money you earn on that spend dollar. Like there, it's just on the index. Like if it's like 1.5, like for every dollar you spend, you generate $1.5. As a net, you generate 50 cents. So let me just show you. It's the way it's calculated similar to NPV, but in NPV you subtract the investment cost. In PI or profitability index, you divide it by cost. That's the only difference. So PI is basically NPV, but guys, don't divide this NPV because in here we already subtracted the cost. Rate is 10%, and my values are here. Close it and divide in it. Like, okay, in NPV, I used to put the minus here. I used to put minus, but I'm gonna put division. Divided by investment cost. Once my investment cost is negative, I need to remove that negative sign because index cannot be negative. I put negative sign here and divided by this amount. So if it's more than 1, then you accept the project. If it's less than 1, you don't accept the project. 1.03. It's very close to 0. So if it was exactly 1, it could mean like $1 you invest. But if you put the IRR here, guys, if you put the IRR here, it will be exactly 1. Means that $1 you generate for $1 you spent. Whatever you spent, you generate exactly the same amount. You're not making any dollar, you're not making any loss. So this one, okay. But in here, why do they add the cost? Because NPV, it's not NPV function in Excel. Look, guys, don't confuse. Most of the students from the previous semester, they confused it. NPV function with the NPV itself. NPV function in Excel, what does it mean? It means you're taking the just present value of cash flows only and adding them up. But NPV itself is what? Present value of cash flows minus the cost. In here, in formula, it has the cost subtracted. NPV. It's not the NPV from Excel. Okay. In here, as you can see, I'm just using the NPV function, but without subtraction the cost. If I subtracted the cost, let's say in here, I'm gonna use the correct rate. This is my NPV, yeah? If I wanted to use this one to calculate the profitability index using the formula, I would do the same thing like this minus, or I'll put the plus to remove plus this cost, yeah? This investment cost and divided by investment cost. And I will get the same answer. No. I should put the minus here. Yeah. Okay. Did you get it? So investment cost should be added here. I was subtracting it, but it should be added. So use it this, like discount all future cash flows and just divide it by investment cost. And this is the profitability index. So overview of the 6 decision models. Payback period, simple and fast, economically unsound, ignores all the cash flow after the cutoff date. So cutoff date is the goal date or set date that you have just put it initially, the preferred date, ignores the time value of the money, while the discounted payback period, it just solves the problem with the time value of the money, but it still ignores the cash flow after the cutoff date. NPV is economically sound, properly ranks the project across the various sizes and the time horizons. IRR provides a single measure. It's very easy to interpret. However, has got some potential for errors in ranking projects, as you saw it. MIRR solves some of the problem, but not all of the problems. Still has got some concern. And profitability index. That's it about this chapter. It's kind of straightforward chapter. What is remaining to solve the end of the chapter questions? So guys, I would like you to solve the end of the chapter questions until tomorrow. Try to solve all of them before you meet me. Okay? We come together and we go with your questions and answers. Solve all of the chapter end of the questions in the NPV chapter. Do we have something here to solve? Yeah, additional problems. We're going to be solving these additional problems now with you, like for the remaining 10 minutes. But whatever we don't solve now, but please solve everything tomorrow. And anyone who wants to see me today, I will be in my office at 4 o'clock. Okay? But don't come before 4. Exactly 4 and after. Okay. Let us go with this question. Regions Bank is debating between two purchase of two software systems, initial cost and annual savings, which are listed below. Most of the directors are convenient that given the short lifespan of the software technology, the best way to decide between the two options is one basis payback period of 2 years or less. So they put the cutoff period as 2 years, and you need to calculate the payback period of each state which should be purchased. One of the directors states like, I object, given the hurdle rate of 10%, we should be using discounted payback period of 2 years and less, rather than just calculating the payback period. So basically, you're given software option A, software option B. You can calculate the payback period for them, or what you can do, somebody's drawing from the guys, they got bored actually. So here, A, and here's the B. So what you will be doing, like for the payback period, you will be just subtracting from this cash flows until. So the first one, if you subtract, and the second cash flow will be generated, as you can see here, will be more than enough. So basically 1 plus whatever the amount will be left, like, will be divided by 900. Is the second year cash. We'll give you the exact number payback period. And the second one too. So if you go with just payback period, you will understand that the first one is giving you less time to cover the cost. It will be quicker in terms of covering the cost. So you might be willing to go with the option A if it's just payback period. However, the another director said like we should not just ignore the time value of the money. We should take it into account. It's very important. So you need to discount all. So all cash flows when they're discounted with a discounted payback period, the first one will take like more than 2.5 years. The second project will take 2.45 years. So based on the discounted payback period and the second year cutoff, both options are not preferable. Like, because you put the cutoff period date as 2 years and less. So if you want me to illustrate one of, it's like, just go with it, just a second. I'm gonna put it here. Okay. This is discounted value. I don't need it actually. So again, this much is left to cover. And from 900, we can see it's more than enough. So I will be using just 1 year. So 1 plus, put the negative sign to remove the negative sign of this, divided by 900.
But we don't choose the year 3 at home, right?
Yeah, we don't use the 3 year. That's the problem of the payback period. Like it ignores the cash flow once it covers the cost. Even the cash flows might be higher. For the discounted payback period, you do the same thing. Like you discount the values and you do calculate this in the same way. For this project, I will do the calculation that way, like plus this. So as you can see, I need just 750 from 800. I'm not going to use the whole amount. So basically 1 plus, open the brackets, put the negative sign here, and this divided by 800. And again, it's going to give you 1.93. So the first option is preferred. It takes less time to cover the cost. And you discount them. Okay. Lucy Hardware expanding its product line and its production capacity. The cost is expected cash flow of the project given below. The firm typically uses 15.4%. So we are given two production. One is like expansion, and the other one is capacity expansion with the 15.4%. So you're just using the NPV function. You can calculate the NPVs for both. So you should make a decision if it's mutually exclusive or independent, depending. So please be careful whenever you will be reading the question. If it's independent projects, I might ask you which project, what will be your decision? You might say that I will accept both projects. If it's independent. If it's mutually exclusive, then means you need to select only one project. And one project you will be selecting here is with the higher NPV. Read the question carefully. Try to get the keywords like it's a mutually exclusive or independent project. If it's independent, I might ask you, what is the decision? Then you should say, if you say that I will select project B, then your answer will be wrong. You should select both projects. If it's mutually exclusive, you will select only one project. Make sense? Okay. Okay, I'll stop here. Thank you so much. Those who are online, please don't leave it. I will send the file so that you can share with the class. I'll just close it. I'll save this file. Don't leave the class, please.